Okay, so today I think is the 13th. So we are looking at just part C, correct?
Yes.
Okay, so we have a function which is f of x, which is x divided by the square root of 1 plus 3x minus 1. And we're asked to find the limit as x approaches 0 from this f of x. Okay? So the limit laws, first of all, it's a ratio, right? So I will say if the limit from the top exists and the limit from the bottom exists, and as long as it's not 0 over 0, right, I will have to, if it's not 0 over 0, but it is, so I cannot really split it. I cannot say limit of x as x approaches 0 and the limit of this as x approaches 0 because I have 0 over 0. So I wouldn't be able to do that. So what I would do to this function, I would rationalize the denominator. So that's why I wrote it on the side. So I will write 1 plus 3x plus 1 over the square root of 1 plus 3x plus 1. And then this function becomes x, the square root of 1 plus 3x plus 1, everything divided by 1 plus 3x minus 1, because it's the first term squared minus the second term squared. These two go away. So then this is x, the square root of 1 plus 3x plus 1 divided by 3x. So I change the function. I simplify now. So I'm assuming you did the part 1 and part 2. So now the simplified function is this. And now I can use limit laws on this simplified function. So I can write limit as x approaches 0 from the square root of 1 plus 3x plus 1 divided by 3. And this will be correct to write limit as x approaches 0 from the square root of 1 plus 3x plus 1 divided by the limit as x approaches 0 from 3. Then I will continue. Now the limit of a sum of two functions is the sum of the limits as long as those two exist and the limit exists, and that's true. So I have limit as x approaches 0 from the square root of 1 plus 3x plus limit as x approaches 0 from 1 over, and I can write that that's 3. And then I continue. And this is, remember, the two operators can be swapped because this is a continuous function. So the limit operator goes inside of the square root. So I will continue by writing the square root of the limit as x approaches 0 from 1 plus 3x. Now I'm done with this. It's positive 1 divided by 3. Now inside I have the limit of a sum. So this will be the square root of the limit of 1. So I'm applying every possible limit law in case I'm allowed to. And then I'll say limit of 1 is 1, limit of 3x will be 0. But I could have not do it on the raw function because I had 0 over 0. And I cannot say that the limit of a ratio is the ratio of limits because the limit of the denominator cannot be 0. And it would have been 0 in this case. So in order to finish it up, I will write, I can get rid of this now. It's the square root of 1 plus, now this is 0. I can apply the limit to this, plus 1 divided by 3. So now the square root is 1. 1 plus 1 is 2, so the limit is 2/3. So I apply every possible limit law, but I couldn't start on the raw function because the limit of the top is 0. That will be okay, but the limit of the bottom is 0, and that will not be okay. So I cannot apply the limit of the ratio in this case as being the ratio of the limits. Good. Anything else? Anything else that you worked on? Yes? Let me just find your quiz because I return the quizzes and I don't want to forget to return yours. And I still would like to know what do you need me to help you with in order to understand the difference quotient? As I said, only one student simplify the difference quotient. Didn't finish, but simplify the difference quotient. So on this quiz, the highest grade was 8 out of 10. So what do you need me to do in order to show you or make you understand how the difference quotient works?
More practice with applying it in different ways other than just what we saw in the previous quiz.
That's the only way. The difference quotient is f of x plus h minus f of x divided by h, no matter what we do.
I don't think it's just understanding, I think it's just remembering how to do it.
Okay, so is there a particular function that gives you difficulties? Algebra can make us stall in this class. It may not allow us to move forward. So algebra is a big, big part of this course. Very important part of this course. So before we look at Ian's question, maybe is that something on the difference quotient that would be best? Okay, so what was the question?
The question is basically find limit.
Yes?
H approaches 0, or the square root of 9 plus h minus 3 over h.
Good. This is the difference quotient, basically. Okay, so it's on the square root. The square root of x, or just x plus 9. That's what it is. Okay, so any suggestions on this problem?
I can do that. But
How?
plus my last one.
Good. What is it?
9 square root of 9 plus h plus 3 over the same thing.
Very good. Excellent. Good point. Good start. So now, would you tell me what problem this is so for everyone to know? On 200? On 200? No, 2.3, section 2.3.
Yeah.
Do we have the page?
I'll pay that 1.
It's 107.
Okay, very good. So 21 on 107. Perfect. So can anyone continue or help here with this?
I got 9 plus h minus 3 over h times the 9 plus over 9 plus h over 1.
So, yes,
Maybe the top might be 9 plus h minus 9.
correct. Divided by h. The square of 9 plus h plus 3. You square this portion, but not square that portion. Is that clear?
Yeah.
Perfect. And then, of course, these two go away. Eventually, h goes away because it has to. It's the difference quotient. So the h from the top and the h from the bottom have to go away. I mean, the h from the bottom has to go away for sure. Okay. And now the limit is? One over 6 indeed. As h approaches 0, the limit is 1 over the square root of 9 plus 3. Yes.
Oh, on the difference quotient, I thought the purpose of the difference quotient is to find like any point to make the secant. So I don't know why you would want to have plus h, like you can just say f of x and then minus whatever that is required here. Like f,
Are you talking about the quiz?
Yeah.
Okay. So the question is, one more time?
like okay, so based on like what I know about the secant line, I thought you just want any 2 points and then you kind of find the slope with one reference point.
The question is asking you first, I don't want to interrupt, but allow me to just say this. The question is asking you to find the difference quotient and simplify it. That's the very first step. So you are given a function, and let's make one up. Let's make up another function so we can illustrate this again, because I'm guessing that that's what Nick is talking about. Tony is talking about. He says, well, let's look at another example. And also Tommy, I think he said, or Nestor said the same thing. So let's come up with another function. Just make one up, anyone. Any function you want.
X squared over x plus 3.
Good. So we want to find and simplify the difference quotient for this. Okay? So the difference quotient, and we have to remember this. That's a definition, and we cannot get away from this, ever. It's f of x plus h minus f of x divided by h. Is that clear? Yes? Do you want me to illustrate with a graph again to make sure? Is this clear to everyone? This is the difference quotient. Good. So now I have this piece, I have this piece. Believe me, I've done this with my pre-calculus class because of this, the need for in calculus. This is given, this is given. This is the only piece I don't have. So what will I have to write is find f of x plus h first. Can anyone dictate f of x plus h?
X squared over x plus 3 plus 8.
Say it again.
X squared over x plus 3 plus 8.
That's the problem. We don't know how to plug in and determine something and evaluate a function. That's the problem then. Yes, it is x plus h squared over, yes, plus 3, and then minus. Very good. Now allow me to explain, because many students have difficulties with this. It's not uncommon. So when I look at a function like this function, this is what I see. If I don't see this pattern, I will never be able to identify or evaluate the function for anything. So this is the pattern for this function that you just picked up, chose for me. So if I'm told to find f of x plus h, I cannot just pick and choose or do whatever I want. I have to follow the pattern. So in the place of the independent variable, which is x, I have to now fill in x plus h. Is that step clear now to everyone? Okay, perfect. So then I'm coming back here, and I know that this is not a simple situation. It's not. I have to give you that. This is not a simple problem. And the next step I have to do or perform is definitely find the least common denominator. Excellent. And what will be the least common denominator? Because if I have difficulties in identifying the correct least common denominator, then I can't go I can make any headway. So what is the least common denominator? Well, that's the problem again. So not being able to identify the least common denominator, that's another hurdle for us. That's another problem. Exactly. Yes, they have nothing in common. So these two have nothing in common. If two denominators or two numbers have nothing in common, the lowest common multiple has to be the product of the two. You can go around that, right? So this is x plus 3 multiplied by x plus h plus 3. Okay, it will come back to you, but you have to say, I'm not sure about this, I'm going to have to practice it. And then it will come back to you. So now, next step is I have to find adjustments, because if you simply copy x plus h squared minus x squared, you will never get anything. So then this top has to be multiplied by x plus 3, right here. And this top has to be multiplied by x plus h plus 3. I'm going to write them side by side for now because I have to square this first. So this is x plus 3. Can anyone square for us x plus h squared? And I have to remind you, we have a contract on this. Yes? Yes. Yes. Very good. Now here this is easier. I have negative x cubed minus x squared h and minus 3x squared. Perfect. Now I will have to distribute. I can't conclude anything at this stage. So I have to distribute in here. But I know two things must happen. Always when I calculate or simplify or determine the simplified form of the difference quotient. What are those two things that have to happen? Please, tell me.
One is h has to go away.
The h from the bottom has to go away. Although at the end I may still have h in the problem, but that one from the bottom has to go away. And what is the other thing, the second thing that has to happen? Yes, and all terms without h. Maybe more than that, just those terms, but at least the terms without h from the bottom must go away. Otherwise, we made a mistake. Because this is the derivative of the function. This is the slope of the tangent line eventually. Okay, so we will be able to determine if for functions that are differentiable and so on and so forth. That later. Okay, so now, I have x times x squared. So I'm going to flip this already so I don't have to write it twice. So I'm going to do this. So I don't have to have stacked fractions. So I distribute x cubed and then plus 2x squared h and then plus xh squared and then plus 3x squared and then plus 6xh and then plus 3h squared. And now, of course, I ran out of room. I always do. I'm going to copy the rest up here. Minus x cubed minus x squared h minus 3x squared. And the denominator has to be copied. It doesn't go away. Good. So now what do I do? Of course, I expect a lot of terms to go away. Definitely all of those which do not have h. So this with this, this with this, and I hope there is something else, but if there isn't, it's good enough because those terms without h are gone. So x squared, there is no other x squared h, so these will just be combined. And xh squared, I don't have an hh squared with anything else, and a 6xh I don't, and 3h squared. I don't care. I do care now about only one thing, and what is that thing? After I clear the terms with no h, what do I care about now? How? The two keywords in all my classes, I say this all over, all the time. Factor simplify, factor simplify, factor simplify. This has to be right here. Factor simplify, factor simplify. So how will I eventually get rid of h? By? Yes. So I will write it one more time just to make it clear. So this is x squared h, and this is plus hx squared, and this is plus 6xh, and this is plus 3h squared. Divided by x plus 3, x plus h plus 3. I'm going to put this in front here. And, of course, now what?
Isn't x squared h negative?
I have this, and I have this, and then I get this. I'd rather go back and check. And I copied that. I think I'm okay. So, what do I do with these? Very good, excellent. So then I have x squared plus xh plus 3x plus 3h, and that's how the x goes away. And this is the difference quotient. Very similar to the problem we had on the quiz. And now let's say I'm asking you to determine the slope of the tangent line at any point. What would you do?
Take the x of that.
Nope.
Take h approach.
Exactly. The limit as h approaches 0 from this. From the difference quotient. Exactly. Perfect. So this is x squared plus xh plus 6x plus 3h over x plus 3, x plus h plus 3. And now Please tell me what to write.
Okay, so you can cancel out the XH
This goes away, this goes away,
and the H.
and this goes away. And the final form will be
Square plus this x
excellent,
over x plus 3 times x plus
which is,
X squared.
b squared.
that's it. That's exactly it.
Then that just go if you had a
Plug in x.
Oh, so okay, so what I did on the quiz,
Yes,
I didn't like do it like by doing the H thing, but instead because I thought the difference quotient is just what you want to find like the secant line anywhere. So I just said f of x minus f of a over x minus
yes,
a.
but I want, the first question was find the difference quotient and
So
simplify.
the definition of the difference quotient is like that form.
F of x plus h minus f of x over h. Yes. Not to worry, I don't keep all quiz grades. I just want you to be on the right track. Okay? Good. Any questions? And is there anything else that you had difficulties with? Anything else that you would like to ask about?
Could we just quickly look over 25? I got to a certain
Yes.
point and
Yes.
got stuff.
Yes. Let's look at 25. Page or section or
Page
107.
page 107 and number
25.
25. So in 25, we have the limit as t approaches 0 from the square root of 1 plus t minus the square root of 1 minus t divided by t. And this is what we just did. So what was the difficulty with this?
For some reason, I just ended up hitting the. Oh, never mind. I just realized what I did.
Okay, excellent. Good. I'm sorry? 23. Okay. It's again the same thing. It's find the least common denominator at the top and simplify it. Just find the least common denominator, make the adjustments. What is the least common denominator? Good. So then you have x at the top and then 4. So x plus 4 over 4x. And you have to divide two fractions. Good? Good enough? Perfect. Anything else? Anything else? Okay, so let's move on. We are talking about 2.4. I gave you a handout last time. We're going to talk about the precise definition of a limit. That's section 2.4. What does this mean, really? 2.4. This is basically your first proof in calculus. I am going to prove certain things for you, but I am not going to ask you to prove anything other than this. So this is basically the only proof in this class, I would say. Okay, I will explain all these symbols that you see here. This looks like gibberish, right, at this moment in time. It's going to be very easy to understand. However, of course, like with anything, we have to get used to it. So first of all, let me start with a numerical example, and then we'll talk about the definition, and then I will give you the symbols and the explanation with the symbols. So we're given a limit as x approaches 2 from 3x minus 1. How much is this? Perfect. Yes, obviously it says here. And it says, I'm going to explain what this is in a minute. Find the corresponding something, satisfying the above definition, and draw the graph. We haven't even read the definition. I just want to draw a graph of this function. I'm going to show you what happens when x approaches 2 from either side. And then we are going to talk about the rest of the symbols and how we analyze this. Okay. I know from a theorem from last time that if I'm given a function that is a polynomial function, if you remember from the previous handout, if the function is polynomial, like what function is this? Linear, excellent. So it's a polynomial function, specifically linear. If I'm given something like this, I'm allowed to, or I should say not allowed to, but I can determine the limit by plugging it in, right? I'm plugging in 2 times 3 is 6, minus 1 is 5, right? So for this function, we discussed, and for rational functions, as long as this number is in the domain of the rational function, I can say the limit can be determined by plugging it in. Although it's kind of a contradiction, right? When we say x approaches 2, we really mean it approaches 2 from either side, but does not take 2 at all. Does not touch 2. However, it turns out that the limit will be the same as if I would plug it in, but I'm not really allowed to plug it in. Okay? Good. So let's look at the graph. I'm going to graph this function basically around 2. I'm more interested in a couple of values left and right of 2. So when x is 0, y is -1. When y is 0, x is 1/3. Kind of difficult to graph, but I know that this is 1, this is 2, this is 3. When x is 1, I have 2. And when x is 2, I have 5. And when x is 3, I have 9 minus 1, which is 8. Okay, I have to go to the next page. I didn't plan ahead. So here, 1, 2, 3, 4. At 1, I said is 2. At 2, 3, 4, 5. And at 3 is 7, right? It's 8. 5, 6, 7, 8. So this is our function. So this is f of x equals 3x minus 1. This is the 2, and this is the 5. And I hope you agree that if I say to you that as x approaches 2 from either side, the function values definitely approach 5. Would you agree? Right? From either side of 2, function values from both sides approach 5. And here it is. That's 5. Okay? Good. Now, in order to show that this is true, although we see it's true, but we want to show in a formal way that this is true, we're going to look at an interval, which is a symmetric interval around 5. I am given here, I am given this so-called epsilon. Epsilon is 0.012. So I am going to choose the given epsilon and create a symmetric interval around 5. Did I start that? Yes, I did. Okay, a symmetric interval around 5. And I know you will know, and you know that, this particular point then must be epsilon 5 plus epsilon. Would you agree? It's a symmetric interval, and this is epsilon. And this point here is definitely 5 minus epsilon. So with a given width, I created an interval around 5. Do you agree? Is it clear? Because the limit exists for any epsilon, not just for this one, but I'm going to illustrate for this one. For any epsilon, I will be able to, here's what I do next. I draw horizontal lines till the function, till it meets, those horizontal lines cross the function or touch the function. and here as well. I created now a point, and I created also another point, right? This point is f, if you need it, right? F of 5 minus epsilon, right here, right? This height. It's some x, but the y value is 5 minus epsilon. And the same thing here is another point with some x, and the y value is 5 plus epsilon, right? Good. Of course, I'm going to go down to x. I'm going to draw now vertical lines from those values, from those points. And I can see that around 2, I can create 2 symmetric intervals. Here's one. With this width, and here's another. With this width. Acceptable so far? Allow me to start from the beginning. For any epsilon that I can create, that I choose to create a symmetric interval around 5 with, I choose an epsilon, any epsilon you want, as tiny as you want. It can be 0.012, it can be 0.00001, it can be as small as you wanted it to be. I will always be able to create this interval around 5. Would you agree? Okay. Then from that interval, I will always be able to create or draw these horizontal lines. They will always meet the function somewhere. And from those points, I will always be able to create a symmetric interval. In this case, it happens in most cases. Two symmetric intervals around 2. Now, this says this, that for any epsilon, I can create a delta. What is delta now? Delta is either this tiny piece in case I choose the smallest width, or is this bigger piece in case I use the bigger interval. Now this is the key that follows. One more time. For any epsilon, I can find a delta around 2. For any epsilon that I choose to create an interval around 5 with, I will be able to create a delta or interval around 2 with a width of delta. And now the key, such as or such that every time I pick an x in this interval, that's the key. That's the part that is the key. Every time I pick an x in this interval, now you tell me where I could pick it. Can I pick it here, or can I pick it in the big interval, in the smaller interval, or in the big interval? Such that every time I pick an x close to 2, delta close, the distance between the x I pick and 2 cannot be wider than delta. So every time I pick x close to 2, not further away than delta, because I cannot pick here. This is way bigger than delta. I have to pick close to 2, then not more than delta. F of that x will fall within epsilon of 5. This mechanism happens only because the limit exists. Don't forget what you want to ask. 1 second. So if the limit does not exist, you may be able to find some epsilon for which you find some delta. But the key is for any epsilon, I can find the corresponding delta, such that when I pick x in there, f of x will fall within epsilon away from 5. Yes, Ian?
We just have 2 questions.
Yes.
What is the difference between what we did earlier? Like not with that's not delta, but now with the x.
This is the proof that the limit is true, to be 5 in this. This is the formal definition. This is the formal, precise definition, or if you want, formal definition of the limit.
Well, we get the same answers.
We're not getting answers here. we're not getting answers here. Here we're saying this. The limit for this function when x approaches 2 is 5 means for every epsilon I pick, I will be able to find a delta such that when I pick an x within delta away from 2, f of x will be epsilon away from 5. We're not proving anything. We're saying if this happens, this mechanism has to happen. If this mechanism has to happen, then the limit is 5. We're not determining the limit. We're just saying if this is true, then the mechanism has to happen. If the mechanism happens, then the limit must be 5. It's a different way of saying the limit exists, and it's 5. We're not going to use, hold your thought, we're not going to use this to do anything else but exercise our understanding on the formal or precise definition of the limit. We're not going to do anything else with it. Yes, please.
So, okay, so let me get this straight.
Yes.
So,
I-
so before this,
It's very good that one of you will rephrase it because I'm sure everybody will understand it, even more.
so, okay, so before this definition,
Yes.
that intuitive kind of thing to
We
determine.
used other theorems. We used the theorems of the limit of a polynomial can be determined in such and such way. We use the limit laws. We use simplifying, rationalizing, and so on and so forth. Yes.
So basically, that will bring out the intuitive L, that limit. But now, in this case, we're trying to prove that L is actually the L, right?
Exactly.
So this doesn't really determine.
That's true.
So
It just shows that if this is indeed 5, then the mechanism behind the curtains has to be this.
So we can use this to check answers.
No, you cannot use the check answers. You can only say if the limit is 5, then if I pick any epsilon around 5, I will find a delta around 2. That if I pick an x near 2, then f of x will be in that interval. And that's why I'm going to ask you now, which of these two intervals will I have to pick? The smaller or the bigger? Here's, before you answer, what if I pick x here? Using the bigger interval, this is what happens. Does that f of x fall within epsilon away from 5? No. So I have to stick with a smaller interval. Yes, please.
Why, I'm not getting the placement of I understand it's supposed to be around 2, but why is one larger and why is one smaller exactly?
Very good. So I'm just going to do this again, maybe at a more acute angle. So let's say this is 5. Let's say this is my epsilon. I'm going to enlarge it a little bit. So the smaller of the two distances between these two, this is definitely the smallest, will create this interval. The bigger, it has to be symmetric. So the bigger one will be this. But I can pick, so in other words, if I consider this to be delta, what if I pick x here, which is still smaller distance than delta, then here's what is going to happen. It's outside. It's not going to be epsilon away from 5.
I guess I just missed that it had to be symmetric.
Yes, it has to be symmetric. Yes, please. Tony.
Just when we're determining the bounds for 5 in this case, I know we're given the epsilon. That is.
Oh, we're going to finish the problem. We did not finish the problem yet.
Okay.
But go ahead.
Then the way the boundaries are actually determined is just plus or minus away from 5 given the epsilon. Right?
Yes.
Okay.
Yes. Okay, so let's come back and determine delta. So now the mechanism, one more time. I know I'm going to repeat it several times because then I'm going to explain those symbols. Do you have to use the symbols? No. I prefer using the symbols because otherwise I have to write all this down. because a problem like this will require you to write the definition. So if I write the definition, it takes me 3 minutes, but if I write this, it takes me 1 minute. And I will explain each and every symbol here. Okay, so allow me to read this, and then we'll come back, we finish the problem, and then we'll move on to other problems. The limit of f of x as x approaches a is L. It means, or it happens if and only if, or it means, for every epsilon, and of course epsilon, I didn't say, but it's clear epsilon has to be a positive number. I cannot have a negative distance anyway. So for every epsilon greater than 0, there is another number that is called delta, and always delta will depend on epsilon, such that this means the distance between the number I pick, x, the distance between x and a, because a is our 2 in my example, is less than delta, will always imply that the distance between that particular f of x and the limit must be less than epsilon. Yes?
You have to memorize that what it's saying
Yes.
for example.
Yes. Yes. Once we solve 3 problems, you're going to dream about it, because it's going to be over and over the same thing. Okay, so let's finish the problem now. One more time, the problem says, for each given epsilon, we are given the epsilon, find the corresponding value delta, which we didn't find yet, satisfying the above definition, and draw the graph. So we did we presented the graph, we showed that this is what we expected it to be. We were given epsilon, now we have for this particular epsilon, and then I would like you to invent another epsilon so we can determine another delta. Okay, so very good. So now I have that 3x minus 1, right, equals 5 minus epsilon. And I have 3x minus 1 equals 5 plus epsilon. Right? So these are these points. So this point is P of 2 plus delta and F of 2 plus delta. And this point here, I'm going to call it Q, is 2 minus delta and F of 2 minus delta. Are we in agreement with that? So this point has the x-coordinate 2 minus delta. This point has the x-coordinate 2 plus delta. And this point has to have the same y-coordinate, which is 5 minus epsilon. And this one has a y-coordinate, which is 5 plus epsilon. So what I'm going to do, I'm going to set f of 2 plus delta equal to 5 plus epsilon. I'm going to set equal 5 minus epsilon equal to f of 2 minus delta. I will find a delta from here. I will find a delta from here. And which of the 2 deltas will I accept? The smaller of the 2. Okay, which I kind of know which one is going to be, but let's go ahead with both calculations for now. So in this x, I have to plug in 2 plus, so for 5 minus epsilon, I have 2 minus delta. So 3 times 2 minus delta minus 1 equals 5 minus epsilon. You can plug in epsilon now. I'd rather plug it in at the end. And the other one is 3 multiplied by 2 plus delta minus 1 equals 5 plus epsilon. Question. Let's come back for a second. Do we understand how we got these numbers and the equations? Yes? So if this is 2 minus delta, this has to equal 5 minus epsilon. And this is f of 2 minus delta has to equal 5 minus epsilon. And f of 2 plus delta must equal 5 plus epsilon. Agreed? Okay. Perfect. So let's solve. I'm solving for delta, of course. So I have 6. I'm solving the first one. So 6 minus 3 delta minus 1 equals 5 minus epsilon. So negative 3 delta plus 5 equals 5 minus epsilon, right? 6 minus 1 is 5, 5 on this side, negative epsilon. So that I have negative 3 delta equals negative epsilon. What is the conclusion about delta? Very good. So that's from the first one. Let's try it and see what we get from the second equation. So from this equation, we obtain this. Are you in agreement so far? Okay. Now I have 6 plus 3 delta minus 1 equals 5 plus epsilon. So this is 3 delta. And look at how nice. This is 3 delta, and this is plus 5, and this is 5 plus epsilon. So delta equals epsilon over 3. So knowing that this is the relationship, no matter what I do, for any epsilon, in order to determine delta, what do I have to do to epsilon? What do I have to do to epsilon to get any delta? Exactly. So we were given that 0.0, was it 1 0 or 2 zeros? 1 0. 1 2. Can anyone give us the delta corresponding to this one? Make up another epsilon. Any epsilon you want. I'm sorry? No. You want to show that it's as tiny as possible. If you zoom in as much as you can, if you zoom out, then, of course. Okay. So how much is delta? Whatever divided by 3. And you can continue forever. Why is this happening? Because the limit exists and it's 5. Let me give you an example in which the limit does not exist. And this mechanism doesn't work. Here's an example in which the limit does not exist. So let's say I have here 5, and let's say I have here 2. And you could say, yeah, but if you take this epsilon, right, you will be able to find that interval. So if this is your epsilon, then this is your delta. How can you say that the limit doesn't exist? Yes, but the limit, the definition says for any epsilon. Here's what happens for a tiny epsilon in this case. Where do I go? How do I get the interval around 2? I can't. So the key is for every epsilon, this mechanism works. Why? Because the limit exists. And that's the key. Okay, let me show you. This is optional. It's a little bit more complicated because these functions are quadratic. Again, I'm considering it optional. So let's stick with, this is a simplification problem. So let's stick with any of those two. Tell me which one you want to work on. Or you can say, I want to choose my own linear function. And you can choose your own linear function, give it to me, and let's show that the limit using the precise definition. Give me any limit from any linear function when x approaches whatever you want. Let's invent one and work on this. Allow me to